Alright, so this video is just going to be a very quick discussion on all the different types of functions that you have worked with. So the first one is linear functions. You should know these probably as y equals mx plus b, where the m is your constant rate of change. Right? So this is our rate of change. We're going to use we are going to use lines a lot in calculus in terms of modeling different situations, okay? And we're going to have specific kinds of lines that are going to be important to us. So m is your rate of change. B, you can always think of that as like a starting point. I know that's your y-intercept if you graph it, but if you think of it as a starting point, then that helps you whenever you go to model real-world scenarios that fall into a straight line. So obviously the graph of this would be a line that has some sort of slope to it, going up, going down, or straight across. A polynomial function is of the form, we have ax to the n plus, I could have like bx to the n minus 1 plus, I could have a ton of terms in here, and then we have a constant at the end, right? So basically like one single line, x to some power, we have some coefficients in front. Polynomials can look a lot of different ways. Usually you'll see this as just like a generic graph of a polynomial, something like that. A lot of times what we concern ourselves with polynomials are the intercepts where they cross through the x-axis. But that is the basic of a polynomial there. One thing to note about a polynomial is that all polynomials are what you consider to be continuous everywhere, which means the domain of every polynomial function is all real numbers. Power functions is just a single term where I have x to some power. Okay, and we'll split this up into if n is an odd exponent or if n is an even exponent. So if n is odd, all of these things kind of take on the shape like that. So think of x to the third, x to the fifth would look like that, x to the seventh, and so forth. What happens is around 0, as the exponent gets bigger, the graph gets a little bit flatter through there and then steeper on the sides. And then the same thing with even, except the ends go in the same direction, right? So if you have x squared, it looks like that, but then x to the fourth, x to the sixth, eighth, so forth, also look like that. Again, a little more square at the bottom and then steeper on the sides. Root functions. We have an nth root of x. Okay, so a root function, again, we'll split this into n being odd and n being even. You're probably more used to the even ones, so you're thinking of a square root. A square root function looks like this, and any even root would look like that as well. Essentially, it's a parabola that's turned sideways, but you're only seeing the top half of it. And then an odd root would look kind of like this, into the third, into the fifth, so forth. So notice it's very similar to what your power function is. It's just laid down instead of standing up. Okay, rational functions. If you have a rational function, that means you have some kind of division going on. And typically you'll see this in the form of a polynomial divided by another polynomial. When you graph rational functions, a lot of times what comes into play when you graph rational functions is you get some asymptotes somewhere. But then again, these can look a lot of different ways. This is just one generic rational function. But a lot of times you get asymptotes and you get graphs that do things like that, where they're split into two different parts. Again, you can have a hole in the graph somewhere, not just asymptotes, but all of those things come into play whenever you start dividing polynomials. You get some values that don't work, and you get asymptotes and holes from that. Trig functions, things like y equals sine x or y equals cosine x. Hopefully you know what those look like. Again, sine would look something like this, but it keeps on going, right? And it keeps on going on this side and continues on forever and ever. And same thing with cosine, where it would look like this, but then it would just keep on going to both sides forever and ever. Okay, So trig functions, sine x, cosine x, tangent x, things like that. And then the last two are inverse of each other, exponential functions and logarithmic functions. Later on in this unit, we have an entire section devoted to each one of these. So exponential functions, think y equals a to the power x. Okay, so now the variable is the exponent. These will come in two forms: exponential growth, if a is a number bigger than 1, and exponential decay, if a is a number less between 0 and 1. Okay, so we have growth and decay there with exponential functions. And then we have log functions. The most common log function that you will see is natural log of x, but this could also look like log and then have a base number, log base a of x. Regardless, when you graph these, it kind of looks like an exponential function, but it's over on the side, crossing through the x-axis, not on top. And again, we've talked about these enough, I think, to where you realize that those two are inverses of each other. But all log functions will look something like that. Obviously, if you have a negative and it's reflected, it could go on this side, but typically on the right side is where you'll see those. Okay, so that's just a basic discussion of all the different types of functions that you have learned throughout algebra, and we will use those in this class.